How's it going, everyone? This is Michael and Neil, Austin Hendrickson. We are seniors at Sacramento State University. This is our final project for Belcush's EEE 178-188 final project of the year. We have completed a dual axis color detection tracker, and yeah, we're ready to get started. Hope you enjoy this video. Our tracker will detect light using 4 photoresistors and track light using a horizontal servo and a vertical servo. Additionally, our tracker can identify a red or blue light with a Raspberry Pi camera. When a red or blue light is identified, the color will display on an LCD screen. A colored headlamp will be used as the light source. We created the surface of our project with 1 piece of wood and 2 metal plates. First, we glued 2 metal plates on top of the wood, creating 4 spaces. The first space was designed for the base. 2 breadboards were placed in spaces 2 and 4. The chip kit Max 32 sits in the 3rd space. For the base, we began by using wheeled-on pipe glue to glue the PVC pipe to wood. Black electrical tape was used throughout the building of this project to provide extra support. Next, the servos were carefully hot glued and placed on top of the PVC pipe. The Raspberry Pi camera was placed on top. Each servo has wire leads, 1 to 5 volts, 1 to ground, and 1 to the Max 32 PWM pins. The servos are controlled by a proportional integral derivative controller, also called a PID, implemented into the chip kit Max 32 microcontroller. Each servo has full range of motion. As the servos are tracking the light, the goal of the PID is to calculate the total air of the servo's movement and drive its air to 0. The proportional component is the driving force behind the system, and the integral component drives the steady state's air to 0. Finally, the derivative component makes sure that we do not have an overshoot.
The color detection splits the images into numpy arrays, which give the color in an RGB scheme. From these values, we can limit the range for a specific color that we're trying to detect. The whole camera screen is separated into pixels, which are counted up for the number of occurrences of each color, then determines if the color is abundant enough to be considered detected, as well as which color is detected. From there, the information is relayed to the Max 32 to change the action of the servos. After a few seconds of not seeing the color determined will return to null. For the basic light test, it's just going to follow the light scenario, and we're going to use this clear light. So what it's going to do is it's going to try to face the light directly. So all photoresistors are trying to get about the same amount of light. If I give too much light to one, it goes directly in that direction. However, if we change the color to, say, blue, what it's going to do now is avoid the light. So if it sees the light, it's going to go away. So it's going down, and they can't get it to come back. So however, after a couple seconds, it's going to go back to the original follow the light scenario, and now it's going directly at the light. Now, the last color we have is red. So if it sees red, it's going to do a top minus left and to control the vertical, and a bottom minus right to control the horizontal, which makes it a very unusual action, which is incredibly hard to control, and I don't actually know what to do to make it move towards me. But again, after a couple seconds, it goes back, and I can just tell it to come back to me. And this concludes our demonstration.
Thank you so much.